Alright, so in this video what we're going to do is we're going to compute the horizontal and vertical asymptotes of these two rational functions. So let me begin with a. Okay, so notice that my numerator in a is 1, my denominator is x squared. So let me begin with horizontal asymptotes. So the numerator is 1, the denominator is the polynomial x squared minus 1. Okay, so the degree of the denominator, excuse me. Alright, so we have here that the numerator is 1, the denominator is x squared minus 1. Sorry, there was a phone call I had to answer. So I'm going to compute the horizontal asymptote. So to compute the horizontal asymptote, I have to take the limit. As x approaches infinity of the function f of x, of course, y. It's going to be f of x. And of course, since the denominator has degree greater than the degree of the numerator, and both of them are polynomials, this is a polynomial in the numerator, not the polynomial is given by 1 times x to the 0, right? It follows then that the horizontal asymptote of this is going to be y equals 0. So here it is. So the limit of this, as the denominator has degree greater than the numerator, is 0. So this implies right away that horizontal asymptote is y equals 0. Okay, so I am done with the horizontal asymptote. Alright, now let me compute the vertical asymptotes. Now to compute, let me actually draw a line here because I don't want to get you confused with this. I'm going to draw two lines. I'm going to draw a line here, and then I'm going to draw a line. Okay, sorry. And then I'm going to draw a line. Come on. Here. Okay? I don't want to confuse you. So I'm working on the problem A above. Alright, so now vertical asymptotes. Let me do the vertical asymptotes. So vertical. Okay, so what I notice over here is that I have no x's in the numerator, so I just have the number 1. So I factor the denominator. Okay, so I'm going to look for the points where x squared, or the x values, the solutions to this equation, is equal to 0. Well, x squared minus 1 equals to 0 implies that x is equal, or rather x squared is equal to 1, and this, of course, further implies that x is equal to plus or minus 1. So the vertical asymptotes of this expression up here, y equals to 1 over x squared minus 1, are going to be the places where this becomes, okay, the denominator becomes 0, and of course they are the line x equals 1 and x equals to negative 1. Alright, so the vertical asymptotes are the lines x equals 1 and x equals to negative 1. Okay, so that's how we do that. Okay, so now let's work on part B. So they're asking us to find the horizontal asymptote of this expression here. Okay, so I begin. So I write y. I'm doing the horizontal asymptote. So I write y is going to be equal to 7 times x squared minus 1. And of course this is being divided by x minus 1. Okay, so here I am. Alright, so I have that. But notice that I can actually take this over here and I can factor it further. So this is going to be equal to 7 times x minus 1 times x plus 1. Sorry about this. Okay, sorry about that. So I factor the numerator, so it becomes 7 times x minus 1 times x plus 1. This over here is the difference of squares, namely the square x squared minus 1 squared. Yes? So now I'm going to divide this. I'm dividing this by x minus 1. Now notice what happens here. I can cancel this out over here. Okay? And in any event, Okay, so that looks pretty nice because I am computing the horizontal asymptote. Okay, clearly the numerator is a higher degree than the denominator. So this implies that there is no horizontal asymptote. So limit um, of f of x. Okay, I'm giving the formal name of the function y is f of x. As x approaches infinity, is going to be equal to infinity because the degree of the numerator is actually greater than the degree of the denominator. Okay, so this implies then no horizontal asymptotes. Right? So we have no horizontal asymptote. Now let's compute the vertical asymptotes. Now I actually did things I didn't need to do for computing the horizontal asymptotes. I actually factored the numerator and the denominator, so I got that y was equal to 7 times x plus 1, and of course my denominator disappeared. So what this is telling me right now is that I also do not have a vertical asymptote. So there is no vertical asymptote for this expression, because when the when the denominator is equal to 0, namely when x minus 1 equals to 0, it turns out that if I plug in the value of x that makes the denominator 0, namely x equals 1, and I plug it into the numerator, I also get 0. So what I end up with is what they call a removable discontinuity. And so we don't have a vertical asymptote in this expression. So no vertical asymptote, right? Since when the numerator is equal to 0, since when I meant to say denominator. When denominator is equal to 0, the numerator is also 0 for that same x value. The numerator is also 0 for that same x value, for that, okay, same x value. Okay, now let me actually check this to make completely sure that you understood what I mean. Okay, so when is the denominator 0 here? It is 0 to the denominator when x equals to 1. Let me plug x equals to 1 here in the denominator. So what do you get? 1 minus 1. That's 0, right? Now let me check upstairs in the numerator and plug in x equals 1. Well, let's see what happens. If I plug in x equals 1 in the numerator, I get a 1 squared, which is 1 minus 1 is equal to 0. So both the denominator and the numerator are 0 for the same x value, namely the value x equals 1. Therefore, we don't have, okay, at the value x equals 1, a vertical asymptote. Thank you for listening. Maybe what I will do before leaving is I will go and check, okay, I will go and check in Wolfram Alpha this particular problem so that you see what's going on. Again, so let me set up the situation in Wolfram Alpha and then I will go there. Alright, so here I am in Wolfram Alpha and I've issued the command plot 7x squared minus 7 divided by x minus 1. This is incorrect here, okay? Let me actually click equals and let's see what I get. So I have 7x squared minus 7 over x minus 1, and if you notice, I said that there were no vertical or horizontal asymptotes, and you can actually see this here, and in fact I'm going to increase the viewing angle of this. So because the viewing angle that I am getting is between -1 and -9.8, so let me increase the viewing angle. Okay, so here it is. So I issue the command plot 7x squared minus 7. Notice that I use the parentheses around the numerator, then this division sign, x minus 1, parentheses around x minus 1, the denominator, and then I comma, x equals to negative 6 to 6. I didn't even say x to x equals 6. All right, and here is what I typed in, x equals to negative 6 to 6. And now you see that my graph goes from negative 6 to 6, and you see that I don't have and my y values actually go from negative 40 to 40. So you notice that I don't have a vertical asymptote, and nor do I have a horizontal asymptote for this expression, which is exactly what I discovered. Okay, so now what I did is I increased the viewing angle from x equals to negative 50 to 50, and if you notice here, so I issued x equals to negative 50 to 50, and again I have no vertical asymptotes and no horizontal asymptotes. Okay, so it is absolutely clear that I don't have vertical and horizontal asymptotes, because certainly my zeros for both the numerator and the denominator are beyond, okay, are within that range. So thank you for listening, and see you later.